In the world of chemistry, understanding the mole is like having a superpower. It's a fundamental concept that helps us make sense of the tiny particles that make up everything around us. Imagine trying to bake a cake and using grains of sugar one by one. It would take forever. That's where the mole comes in. It's like a chemist's counting unit, but instead of counting individual atoms or molecules, which are incredibly small, it lets us count them in huge groups. This makes chemical reactions much easier to work with and understand. Without the mole, chemists would be lost in a sea of atoms. It's the bridge between the microscopic world of atoms and molecules and the macroscopic world we experience every day. Imagine you're buying eggs. You don't ask for 12 individual eggs, you ask for a dozen. The mole is similar. Just like a dozen always means 12, a mole always represents a specific, incredibly large number of things. This number is called Avogadro's number. Think of it this way. If you had a mole of marbles, you'd have enough to cover the entire Earth in a layer miles deep. That's a lot of marbles. So instead of dealing with trillions and quadrillions of atoms, chemists can talk about a few moles of this or a few moles of that. It simplifies things greatly. Avogadro's number is the key to understanding the mole. It's a mind-bogglingly large number, 6.022 times 10 to the 23rd. That's 602 sextillion, 200 quintillion. But don't let that scare you. This number tells us exactly how many atoms or molecules are in 1 mole of a substance. So, 1 mole of carbon atoms contains 6.022 times 10 to the 23rd carbon atoms, and 1 mole of water molecules contains 6.022 times 10 to the 23rd water molecules. It's a bit like saying a baker's dozen always has 13 items instead of 12. Avogadro's number is just the chemist's dozen for atoms and molecules. Moles are used everywhere in chemistry. They help us balance chemical equations, which tell us the exact amounts of reactants needed to produce a certain amount of product. This is crucial in fields like medicine, where precise dosages are essential. For example, chemists use moles to calculate how much of a particular ingredient is needed to create a specific amount of medication. Without moles, it would be nearly impossible to create medicines safely and effectively. Even in everyday life, the mole plays a role. When you bake a cake, the recipe uses measured ingredients like cups of flour and teaspoons of baking powder. These measurements are based on the idea of moles, ensuring that the ingredients react in the right proportions to create a delicious cake. In conclusion, the mole might seem like a strange concept at first, but it's an incredibly important tool for chemists. It allows us to make sense of the vast numbers of atoms and molecules in the world around us. So next time you bake a cake or take medicine, remember the humble mole, working behind the scenes to make it all possible.